Albert Einstein, one of history's most celebrated figures, was born on March 14, 1879, in Ulm, a city in the southern part of the German Empire. At the time, Ulm was a key urban center within the Kingdom of Württemberg, a significant region of Germany. His father, Hermann Einstein, was an Ashkenazi Jew from Buchow, Württemberg. Though Hermann excelled in applied mathematics during his studies in Stuttgart, financial hardships forced him to abandon his education. Instead, he worked in a featherbed shop run by his cousins, Moses and Hermann Levi, in the 1870s. Albert's mother, Pauline Koch, came from a family of German Jews with established business connections in Württemberg. She married Hermann in 1876, and Albert was their first child. 2 years later, in 1881, Albert's younger sister, Maya, or Maria, was born. Albert's early years were heavily influenced by his father's business ventures. In 1880, when Albert was still an infant, Hermann, guided by his brother Jacob's advice, moved the family to Munich. There, Hermann and Jacob established an electrical engineering company, Einstein and Company, to capitalize on the emerging era of electrification. In Munich, Albert attended a Catholic elementary school before transferring to the Luitpold Gymnasium in 1887. He remained there until 1894 when the family relocated again after Hermann and Jacob failed to secure a contract for Munich's electrification. They moved to northern Italy, first to Milan and later to Pavia. Although Albert initially stayed behind in Munich to continue his education, he grew frustrated with the rote learning methods at the gymnasium. He eventually persuaded his parents and school officials to let him join them in Italy. From 1894 onward, Albert continued his education in Italy, where his exceptional talent for science and mathematics became increasingly apparent. At just 12 years old, Albert had taught himself algebra and advanced geometry, studying Euclid's works. By 1891, he was already exploring calculus. The Einsteins even hired a tutor, Max Talmud, to guide Albert in advanced mathematics and science. However, Albert quickly surpassed his tutor in subjects like calculus, algebra, and geometry. Beyond his scientific aptitude, Albert also had a keen interest in philosophy. As a teenager, he delved into works by influential thinkers such as Immanuel Kant. Remarkably, at the age of 14, Albert demonstrated a clear understanding of Kant's Critique of Pure Reason, one of the most complex philosophical texts ever written, leaving his tutor astounded. Recognizing his extraordinary abilities, Albert's family and teachers encouraged him to pursue higher education. Shortly after turning 16, he attempted the entrance exams for the Swiss Federal Polytechnic School in Zurich, a prestigious institution specializing in science, mathematics, and engineering. Although he performed well on the technical sections, his youth prevented his acceptance at that time. Undeterred, Albert passed the Swiss Matura, an equivalency exam, the following year. In the same year, he renounced his German citizenship to avoid mandatory military service. Now stateless, Albert finally enrolled at the Polytechnic School in Zurich in 1896 at the age of 17. There, he studied physics and mathematics, excelling in the subjects that had fascinated him since childhood. After 4 years of study, he graduated in 1900 with a diploma. During his time in Zurich, Albert's research interests began to take shape. His work spanned various areas of physics, including quantum mechanics, where he explored methods for accurately measuring molecular dimensions. He also focused on the nature of light, questioning the prevailing belief that it traveled solely in wave patterns. Albert suspected a more complex mechanism was at play, a theory he would continue to develop in his later work. In 1905, while working part-time and pursuing his doctorate, Albert completed his thesis titled A New Determination of Molecular Dimensions. His research during this period was reportedly supported by Miliva Maric, a Serbian mathematician and physicist who attended the Polytechnic School alongside him. Miliva, one of the few women in the program, was not only a close collaborator but also Albert's romantic partner. Their relationship, however, faced challenges. In 1901, Miliva became pregnant, and at a time when having a child out of wedlock was highly stigmatized, this posed significant societal pressure. While the extent of Maleeva's contributions to Einstein's work remains unclear, her role in his early research is now widely acknowledged. Albert's groundbreaking work during this formative period laid the foundation for his later contributions to science, ultimately reshaping our understanding of the physical world. Maleeva Marek, Einstein's first wife, returned to Serbia when she gave birth to their daughter, Lieserl. What happened to Lieserl afterward remains uncertain. Some reports claim she passed away in 1903 from scarlet fever, while others suggest she was adopted in Serbia. It's more likely, however, that she passed away early, as Einstein and Maleeva got married in January 1903. Later, the couple had two more children, Hans Albert, born in 1904, and Eduard, who arrived in 1910. Interestingly, Einstein's journey to finding a teaching position after earning his diploma in Zurich in 1900 was anything but smooth. For over a year, he struggled to secure a junior academic role at a university in Central Europe. Meanwhile, he became a Swiss citizen in 1901, formally gaining citizenship after years of being technically stateless. A breakthrough came through Max Grossmann, a friend from the Zurich Polytechnic, whose father helped Einstein land a job at the Swiss Patent Office in Bern. At the Patent Office, Einstein worked as an assistant examiner, evaluating inventions and ensuring inventors received credit for their creations. While the role supported his young family, it also exposed him to concepts in electrical conduction and mechanics, which may have influenced his early research. Einstein's rise from obscurity to becoming one of Europe's most prominent physicists is a remarkable story. While working at the Patent Office, he pursued his doctoral studies and published several groundbreaking papers in Annalen der Physik, a leading physics journal. In 1905, 4 of his papers, each a significant contribution to physics, came out, making that year known as Einstein's Annus Mirabilis or Miracle Year. The first paper, published on June 9, 1905, was titled On a Heuristic Viewpoint Concerning the Production and Transformation of Light. It explained the photoelectric effect, where light hitting a material causes it to release electrons, later called photoelectrons. Before Einstein's work, light was widely believed to travel solely as a wave. His research proposed that light also behaves as discrete packets of energy, or quanta, which can't be divided further. This insight not only advanced the understanding of light and electrons but laid the groundwork for quantum mechanics. Decades later, this discovery earned him the Nobel Prize in Physics, even though it took years for the scientific community to accept his findings. Just weeks later, on July 18, Einstein's second paper, on the motion of small particles suspended in a stationary liquid, introduced an innovative way to measure molecules. Building on the concept of Brownian motion, Einstein used pollen particles suspended in water to show how atoms and molecules, previously theoretical concepts, could be observed and measured. This work, alongside further research by French physicist Jean Perrin, provided undeniable proof of the existence of atoms, revolutionizing atomic theory. His third paper, published on September 26, tackled the challenges of reconciling James Clerk Maxwell's equations of electromagnetism with classical mechanics. Titled On the Electrodynamics of Moving Bodies, it introduced the special theory of relativity. Einstein concluded that the speed of light is constant for all observers, regardless of the motion of the light source or the observer. He famously illustrated this concept by imagining himself in a streetcar traveling at the speed of light. In this scenario, the hands of a clock tower would appear frozen to him, even though time would continue normally on his own watch. This groundbreaking idea, that time and motion are relative, reshaped the way physicists understood the universe. Einstein's fourth and final paper of 1905, published on November 21, introduced the famous equation E equals mc squared, which demonstrated the relationship between energy and mass. This equation showed that even a tiny amount of mass could produce a vast amount of energy, laying the theoretical foundation for nuclear energy. While Einstein later expressed regret over the destructive uses of this discovery, such as nuclear weapons, the equation remains one of the most important in physics. These 4 papers didn't just shake up the field of theoretical physics, they laid the foundation for countless practical applications. From solar-powered devices and automatic doors to GPS technology, many modern innovations trace their roots to Einstein's 1905 work. Even nuclear power plants harness energy based on the principles he introduced. Despite the brilliance of these contributions, it took a few years for Einstein's work to gain widespread recognition in the scientific community, as journals and word-of-mouth communication were slower in that era. By 1908, however, his reputation had grown significantly, and he secured a teaching position at the University of Bern, leaving the patent office behind. A year later, he was appointed to a prestigious chair in theoretical physics at the University of Zurich, where he spent 2 years refining his ideas. During this time, Einstein began expanding on his work in special relativity, laying the groundwork for his general theory of relativity. This theory would later explain how massive objects warp space and time, producing the effect we know as gravity. Einstein's early research laid the groundwork for understanding black holes and other massive celestial bodies in the universe. In 1911, after spending over 15 years in Switzerland, Einstein accepted a position at Charles Ferdinand University in Prague, the oldest university in what is now Czechia, then part of the Austro-Hungarian Empire. Along with the job, he was granted Austrian citizenship. During his brief time in Prague, just over a year, Einstein published more than a dozen papers on topics like radiation mathematics, quantum theory, and gravitation. Soon, another opportunity called him back to Switzerland, a teaching position at his alma mater, the Polytechnic School in Zurich. By the summer of 1912, he was back in Zurich, lecturing to students who were increasingly aware of his growing reputation as a groundbreaking physicist. During this period, Einstein collaborated with Marcel Grossmann, a former classmate, on problems related to gravitation and molecular heat. Grossmann, whose family had once helped Einstein secure a job at the Bern Patent Office, played a key role in supporting Einstein's research. In the spring of 1913, less than a year after his return to Zurich, Einstein received a visit from 2 prominent scientists, Max Planck and Walther Nernst. Both were based in Berlin and came to persuade Einstein to accept a position at the University of Berlin. The offer was irresistible: membership in the prestigious Prussian Academy of Sciences, directorship of the Kaiser Wilhelm Institute for Physics, and the freedom to focus entirely on his research. Additionally, the move to Berlin brought him closer to his cousin Elsa, with whom Einstein had been corresponding frequently since 1912. By early 1914, Einstein had moved to Berlin. Although his wife, Mileva, initially moved to Berlin with their 2 sons, she quickly became unhappy with their new life, sensing Einstein's growing closeness to Elsa. Mileva eventually returned to Zurich with the children, and the couple separated. They officially divorced in 1919, and Einstein later married Elsa, who brought 2 daughters from her previous marriage into their new family. Einstein's arrival in Berlin coincided with the outbreak of World War I, a conflict that had been brewing due to colonial rivalries, power struggles in the Balkans, and an arms race between major European powers. The war officially began in 1914, and Germany's invasion of neutral Belgium led to widespread condemnation. In response, prominent German academics issued the Manifesto of the 93, a document supporting Germany's war efforts. Einstein, a lifelong pacifist, refused to sign it and instead co-authored the Manifesto to the Europeans, calling for unity and a peaceful resolution to the war. Unfortunately, the war dragged on for 4 brutal years. Despite the challenges of wartime, Einstein managed to continue his research in Berlin. The Kaiser Wilhelm Institute for Physics, with Einstein as its director, was finally established in 1917 after delays caused by the war. He held this position for 16 years, during which he joined the German Physical Society and received numerous international honors, including membership in the Royal Netherlands Academy of Arts and Sciences in 1920 and the Royal Society in 1921. Einstein's research during the mid-1910s was groundbreaking. In 1916, he predicted the existence of gravitational waves, ripples in spacetime caused by massive objects. Although these waves couldn't be detected at the time, they were finally observed a century later, in 2016, by American scientists. Around the same time, Einstein also began theorizing about black holes, regions of spacetime where gravity is so intense that nothing can escape. This work would later revolutionize our understanding of the universe. Not all of Einstein's theories were correct, though. In 1917, he proposed the cosmological constant, suggesting a static universe. Years later, astronomer Edwin Hubble's discovery of the expanding universe proved Einstein wrong, and he famously called it his biggest blunder. One of Einstein's most significant achievements during the war years was his general theory of relativity. Building on his earlier work on special relativity, Einstein developed a geometric theory of gravitation that went far beyond Newton's understanding of gravity. This theory was groundbreaking, though mathematician David Hilbert arrived at similar conclusions independently around the same time. The two corresponded and likely influenced each other's work, reaching their final conclusions within days of each other in late 1915. When the war ended in 1918, academic life began to resume across Europe and America. In 1919, Einstein's general theory of relativity was confirmed by English astronomer Sir Arthur Eddington during a solar eclipse. The discovery made headlines, with newspapers proclaiming that Einstein had overturned Newton's long-standing model of the universe. In 1921, Einstein was awarded the Nobel Prize for Physics, specifically for his work on the photoelectric effect from his 1905 paper. However, the award could easily have recognized any number of his groundbreaking contributions over the preceding years. Following his Nobel win, Einstein and his wife Elsa began traveling extensively. In 1921, they arrived in New York City to a grand welcome, met with the city's mayor and prominent members of the Jewish community, and gave lectures at Columbia and Princeton universities. Einstein even met U.S. President Warren Harding before continuing his travels to Japan, Singapore, India, and Palestine, where he observed the growing Zionist movement. Einstein's travels continued throughout the 1920s, including a 1925 tour of South America, where he visited Argentina, Uruguay, and Brazil. By this time, Einstein was a global icon, celebrated not only for his scientific achievements but also for his contributions to peace and international cooperation. In the mid-1920s, Einstein found himself in the middle of a heated scientific debate that captured a lot of public attention. The clash was between him and Niels Bohr, a Danish physicist who had won the Nobel Prize in Physics in 1922, just a year after Einstein had been awarded the same honor. The debate centered around their conflicting views on quantum theory. A key point of contention was Bohr's initial refusal to believe in the reality of photons, a concept Einstein had first introduced in 1905. Bohr didn't fully accept the idea until 1925, and even then, their arguments about quantum mechanics continued to flare up. Their disagreements were discussed in London and other cities between 1922 and 1925 but ultimately peaked at the Fifth Solvay Conference in Brussels in 1927. Both Einstein and Bohr presented arguments at the conference, and interestingly, they both turned out to be right in different ways. What made the 1927 Solvay Conference particularly remarkable wasn't just the debates, it was the sheer brilliance of the attendees. Out of the 29 participants, 17 either had already won or would go on to win Nobel Prizes. Alongside Einstein and Bohr were other scientific legends like Marie Curie, Werner Heisenberg, and Erwin Schrödinger. The event was a testament to the unparalleled intellectual brilliance of Europe's scientific community during the interwar years. In the late 1920s, Einstein began rethinking some of his ideas about the universe. This shift was sparked by Edwin Hubble's groundbreaking discovery of the recession of the nebulae, now known as Hubble's law. Hubble revealed that galaxies are moving away from Earth at speeds proportional to their distance from us, and the farther away a galaxy is, the faster it's receding. When Hubble's findings were published in 1929, they directly challenged Einstein's existing view of a static universe, known as the cosmological constant. Einstein had to rethink his assumptions, realizing that the universe was actually expanding at an accelerating rate. This discovery also inspired Einstein to visit the United States in December 1930, where he met Hubble in person to express his admiration for the astronomer's work. However, the trip is best remembered for Einstein's 2-month fellowship at the California Institute of Technology, Caltech. While in California, Einstein shared his growing concerns about the dual nature of science, its ability to help humanity but also to cause great harm, particularly with the rise of military technology. This perspective resonated with prominent pacifists like Upton Sinclair and Charlie Chaplin, both of whom Einstein met during his visit. Einstein and Chaplin hit it off, leading to a memorable moment when Einstein attended the premiere of Chaplin's film City Lights. As Einstein entered the theater with Chaplin, the crowd greeted him with the same enthusiasm reserved for Hollywood stars. Their friendship continued, with Chaplin even visiting Einstein's home in Berlin before Einstein returned to the US in 1933. Meanwhile, back in Germany, the political landscape was rapidly deteriorating. After years of economic turmoil following World War I, Germany entered a brief period of stability in the 1920s, only for it to be shattered by the Great Depression in 1929. As unemployment soared, many Germans turned to the Nazi Party, led by Adolf Hitler. By 1933, Hitler had risen to power, transforming Germany into a one-party, fascist state. For Einstein, a Jewish scientist, the situation became increasingly dangerous. After 2 police searches of his Berlin apartment and the growing persecution of Jewish academics, Einstein decided to stay in the United States permanently. During a brief stop in Antwerp, Belgium, he formally renounced his German citizenship. In America, Einstein took up a position at Princeton's Institute for Advanced Study in New Jersey, where he would spend the rest of his career. In the late 1930s, he collaborated with physicist Nathan Rosen to develop a theoretical model of wormholes, structures that could, in theory, connect different points in spacetime. While largely speculative at the time, the idea of Einstein-Rosen bridges later became a cornerstone of theoretical physics and a popular theme in science fiction. As Einstein settled into his new life in the US, events in Germany escalated. Hitler's regime began rearming the country and expanding its territory, actions that culminated in the invasion of Poland in 1939, sparking World War II. Initially, the US stayed out of the conflict, but Japan's attack on Pearl Harbor in 1941 drew America into the war. By then, science was playing a major role in shaping the war. In early 1939, European physicists discovered nuclear fission using uranium, paving the way for the development of nuclear weapons. This prospect alarmed many scientists, particularly Hungarian physicist Leo Szilard, who feared that Nazi Germany might build an atomic bomb. Szilard, along with fellow physicists Edward Teller and Eugene Wigner, drafted a letter to President Roosevelt, warning of the dangers. Einstein, recognizing the gravity of the situation, signed the letter, which became known as the Einstein-Szilard letter. This letter played a pivotal role in convincing the U.S. government to launch the Manhattan Project, setting the stage for the nuclear age. The Manhattan Project, the U.S. government's effort to develop a nuclear weapon, began in late 1939, just after the Einstein-Szilard letter was delivered. Although this initiative went against Einstein's pacifist beliefs, the threat of Nazi Germany acquiring such a weapon before the U.S. pushed him to warn the government about the danger. Despite his anti-war stance, which viewed war as a disease that should be resisted by all civilized nations, he did not actively participate in the Manhattan Project. Instead, the project was led by Robert Oppenheimer, a renowned American theoretical physicist. The project's activity was modest between 1939 and 1941, but after the U.S. entered World War II in December 1941, funding and resources expanded significantly, especially as it became clearer that the Nazis were working on a nuclear bomb, particularly in Norway, where heavy water, a form of hydrogen with nuclear properties, was being produced. However, the Nazi efforts were slow, and sabotage operations by British special forces and Norwegian resistance fighters thwarted their progress. By 1942, the Manhattan Project had grown to employ over 130,000 people, and the first successful demonstration of a nuclear reactor took place in Chicago. In mid-July 1945, the world's first nuclear device was detonated in New Mexico. Although World War II had already ended in Europe, the conflict continued in the Pacific against Japan. President Harry Truman quickly decided to use the new weapon on Japan, believing it would save over 1 million lives by hastening Japan's surrender. On August 6, 1945, the first nuclear bomb was dropped on Hiroshima, killing about 75,000 people instantly and another 60,000 in the following months from radiation sickness. 3 days later, a second bomb was dropped on Nagasaki, killing about 80,000 people. Japan surrendered soon after, but Einstein was horrified by the destruction and the aftermath. He later expressed regret that his research on mass energy equivalence, which he published in 1905, had contributed to the creation of such devastating weapons. Shortly after the bombings, he declared, "The time has come now, when man must give up war. It is no longer rational to solve international problems by resorting to war." After the war, Einstein continued to research and publish, although his health and growing public profile limited his productivity. In the late 1940s, he worked on his unified field theory, which aimed to unify the fundamental forces of nature. This theory, published in 1950 in Scientific American, tried to merge elements of his work on general relativity, electromagnetism, and gravity. While his theory was not widely accepted, it significantly contributed to the development of differential geometry, particularly in how it applies to space. Einstein also gained unprecedented celebrity status for a theoretical physicist. This began in the early 1920s after his theory of relativity was confirmed, and he won the Nobel Prize. His association with figures like Charlie Chaplin and his distinctive appearance made him a recognizable figure. By the 1940s, it was clear that Einstein's ideas were not just revolutionizing physics, but also shaping society in practical ways, making him as well known in the public sphere as later figures like Stephen Hawking. Over his career, Einstein published nearly 300 academic papers, which were the primary way of communicating research in hard sciences, rather than books. However, he did publish several books, mostly compilations of his existing papers or attempts to make his ideas more accessible to a wider audience. These works were also translated into multiple languages, ensuring his research reached a global audience. Besides his academic output, Einstein was a prolific correspondent, with over 3,500 pages of private letters housed at the Albert Einstein Archives in Jerusalem. Despite his fame, Einstein remained humble. He once said, "I have no special talents, I am only passionately curious." He lived simply and didn't pursue wealth or fame. His family life, however, was difficult. After his separation from his first wife in 1914, his 2 sons lived with their mother, and their relationship with him was strained. Later, his second marriage to Elsa was also troubled. Nevertheless, Einstein's political views were deeply humanistic. He was an advocate of nonviolence, admired Gandhi's pacifism, and was a critic of capitalism, advocating for socialism and global government. He also supported the creation of a Jewish state in Israel. Although Einstein was born into a Jewish family, he identified as an agnostic and was critical of religious texts. His Jewish heritage shaped his life, especially after the rise of the Nazi regime, which forced him to leave Germany and relocate to the United States. Einstein also became an active supporter of Zionism. He was part of the initial board of governors for the Hebrew University of Jerusalem in 1925. After World War II, as Jews who survived the Holocaust fled to Palestine, Einstein continued to support the establishment of Israel, although he declined an offer to become the country's president in 1952, citing his age and inability to leave the U.S. In 1955, Einstein died from complications of an abdominal aortic aneurysm. He refused surgery to treat the ruptured aorta, choosing instead to face death with dignity. After his death, his brain was removed without the permission of his family and studied scientifically. The findings of the brain study, such as the higher number of glial cells, have been suggested as a factor in his remarkable intellectual abilities. Einstein was cremated, and his ashes scattered in an undisclosed location. Einstein's influence on science is immeasurable. His research changed humanity's understanding of the universe and made his name synonymous with brilliance. Despite his humble beginnings, including his early years as a nomad in Europe, Einstein's work ultimately revolutionized the fields of physics and mathematics. His path from working at the Swiss Patent Office to becoming one of the greatest minds in history is a testament to his intellectual curiosity and determination. Throughout his career, Einstein made groundbreaking contributions to science, was instrumental in the fight against the Nazi regime, and later advocated for the Jewish people and the State of Israel. His life and work have left an indelible mark on the world, and his intellectual legacy continues to influence the fields of physics, mathematics, and cosmology. What do you think of Albert Einstein? Was he the most revolutionary intellectual in modern history? Let us know your thoughts in the comments, and thank you for watching.